So let's start. Look at the third question and choose it is squares of a sorted array. And as the description say, it given an integer array names and sorted in non-decreasing order, and then return an array of squares of each numbers sorted in non-decreasing order. So how it is difficult? Because it is input a non-decreasing order and also output a non-decreasing order. So let's see an example. As we show here, the input is names like this. It have a negative number and zero and positive number, but it should output like this. So how could we get this? As the explanation said, after squaring, the array will become like this. So it's a bit little weird. It's not decreasing, right? So we need to sort it again, and it will become like this. So it is almost two steps. And example 2 is like this, right? It's also two steps: scoring and storing and sorting. And as the constraints say, the length of lambs should greater than or equal to 1, less than or equal to 10,000, and the length at the I element is greater than or equal to negative 10,000 and less than or equal to 10,000, and the length is sorted in non-decreasing order. So we should keep in mind when some information is repeated again. And so in this problem, I will first use intuitive approach. As we can analyze here, it is scoring each element, the first step, and sorting into a new array. So I will use this very simple and intuitive approach. But as the command say, it is trivial. It's very trivial. So I will use another O of n solution. The time complexity and the space complexity are both O of n. So just another approach. So let's get started. Now let's create a long decreasing order like negative 10, negative 5, 1, 2, 4, and 7. And long decreasing means it is sorted from the smallest to the largest, like the array here. But if we go ahead and square every value in this array, it will be like this, like 125, 1, 4, 17, 16, and 49. And if we next step is sorted this array, right? Sort this array, and we can sort it from the smallest to the largest. It will become 1, 4, 16, 25, 49, and 100. And it is a long decreasing order. And so we already got it. This is enough for these problems. So yeah. So let's start. I choose the example 1. This list as our example. We can print it out and iterating every number inside it. Define x for x in this array and sort it. Yeah, we get it sorted, and multiplied by x. X multiplied x is a square, and there we go. we finished. We can return this and define sorted, squared, and self, and define it. It is lambs. It lists name is lambs, and inside it is an integer, and we change this into also to lambs, right? And it will return an list inside the element is an integer, and give them an indentation, and class solution and indentation. Okay, here we go. We can print solution dot sorted. We need to print again and take this and take this. Yeah, it printed out and it works. So let's analyze it time complexity, and in the time complexity is two parts. The one part is a squaring part. It is O of n, and the another part, the second part is a sorting them. It is the time complexity. Because we use the pattern, and pattern is used the team sort, and in team sort is the time complexity is O of n log n, and that is okay, but not enough, because we can take advantage of the input. The input is already sorted from smallest to the largest. We can take advantage of that. And another is when we squaring a number, it will get bigger, and if it is negative, it will turn positive. So like negative turn is in the value in the far left, right? And but end up it will become the largest value in the output. But another is the 7. The 7th value is the far right, but end up it will become the second largest value in the output. And so if we ignore the negative sign, that means we just take the absolute value of each side, and we can notice that the largest value is it is absolute value, right? And the positive, so it is absolute value is positive 10 is right here, and the second value is the positive 7 is in the right side. So we now we know that the largest value is either going on the first value in the array, or the first value in the array, or the last value in the array. And now this value is going to be produce a largest value because we will scoring it, right? This means that either the left value or the right value will going to produce the largest value in the end. And in this case, it means the left, the far left, I mean the first value in the array here, right, become the largest in the output. So we can take more deeply analyze it. So let's try another approach, and I will take all the input data here, negative 10, negative 5, and 1, and 2, and 4, and 7, and I will set the left side with left pointer and the right side with right pointer, and then I will set a empty list, and inside empty list we also have 6 element, and the name is result. Okay, so this is a 2-pointer approach. And why we use 2-pointer approach? Because I want to speed up the running time, and as we all know, the largest value in the array is going to either, I mean, this result value, the largest is either from the left side or the right side. I mean, in this array, it's either the first one or last value will get squatted, and we can compare this by absolute values. I will use a function called I will use the absolute L compare with R. Yeah. So if it is true, the left absolute value is less than the absolute right value, then the biggest value is in the right, or is in the left, and we will take the left value. But if it is a false, we will take the right. We will take the right side value, because the right side absolute value will bigger than the left side, and so we can run it now. Specific is 10 less than 7. Is 10 less than 7? Oh no, 10 is not less than 7. So we know that the left value is bigger than the absolute value, and it is false. And so minus 10 multiplied by minus 10 will get 100, and it will be bigger than, even if after square, it will be bigger than the 7, right? So we take the 100, and it is become the largest value in the result array, and it will get squared, right? And so it is squared. We can, after it's squared, we can update the pointer. So we can remove this to another one. Move on. And so the next smallest value in the array is this one, right? -5. And so now we can compare the absolute value of -5 is 5 less than 7. Oh yes, in this case 5 is less than 7, so we will take the right one, the value of the right, that is 7. So the 7 squared will become 49, right? And so after we use the right pointer, we can move on to the next value from right to the left, and so we look at the 4 here, and we continue it again. Is 5 less than 4? oh no, it is false. 5 is bigger than 4, so we can take the left pointer value, and we can get this and to square it. So we get negative 5 multiplied by negative 5, we'll get 25. And we can move on because we just use the left pointer. We can move on the left pointer to the 1 and continue the values game again. And let's take a look at the 1. And is 1 less than 4? Yes, it is. And in this case, we will take the right point value, right? We will take 4, the fourth value, and the 4 squared will become 16. And from there, we can update the right pointer because we just used the 4. We can update the right pointer to the next low value, and we will take the right pointer to the 2 here, and when we compare, we need to compare whether is 1 less than 2. Yes, 1 is less than 2, so we can use the value of 2 in here and square it. We will get 4. And finally, we can update the pointer, so the pointer will go to the right pointer will go to here. And we notice here the left pointer and the right pointer, they point at the same thing, right? But it doesn't matter. Doesn't matter it is right side or left side in our calculation. We just follow the algorithm because we trust the algorithm that what will happen. So let's just do it. Whether the 1 is less than 1, so in this case it knows 1 is equal to 1, right? So it is false, and we will take the right pointer value, and which is 1. Then we square it, we get it. 1 squared 1 equals 1, and that is our answer. So we just finished this algorithm. Now let's analyze it time complexity, and as we mentioned before, because the first approach we used Python's built-in function, and it is a team sort, and time complexity is n log n sorting operation. But here we get it more simple, and the time complexity we get it is O of n. So it is why is O of n? Because each time we just look at every element in the array exactly only one time. So this complexity is get this algorithm more simple, right? Just for computer. So I finished. So let's start coding. I will first set the variable n, and n is the length of the lambs, and the lambs is our input array. And then I need to set a result variable. It is a list. We will return a list, and I need to use a 0 to as a placeholder to occupy a place, and we need to multiply it by length side. Let me say 5, and let me try to output. It will output 5 0 in this. Every element is 0 inside this array. And let me change to n, so it just occupied n lengths. And then remember we used the 2-pointer approach, so we need to set a 2-pointer left pointer and right pointer. and the left pointer is will start from the smallest. The index is 0 because it is a sorted array, and the right is n minus 1 because n is the length, and it starts from 0, so the n minus 1 is the biggest. So we can try to fill the content into the result. I will use the for loop for I in range, and it will start the biggest one is n minus 1, and will until meet 0, right? So equal to 0. So we need to set the minus 1 less than minus 1, and the minus 1, this minus 1 means decrement 1 by 1, and every time, so it will iterate from the largest it will fill in this array from the largest to the smallest. So the index will decrement, right? And then we need to declare a square. This square, let me say, just say 0 because it will change, right? And then we can use the if statement. If the absolute value of the length at the left is smaller than the absolute value of length at right, that means if the statement is true, the right side is big, so the square will get the right the right side value index, right? Yeah. And after the square get value, we can just update, just move on. So because it is a right pointer, the right pointer should move from the right to left, and it is a decrement in a sorted list, so it will decrement one in because the right pointer is an index, right? And it will decrement 1, and so keep move on. And if else, that means the square can get the names at the left side because it's either bigger or equal to the right side. So we just get the left side, and because we get the left side, we use the left side. We can use increment because the right side is from left to the right, and it will just means smallest to the biggest index, and so it just update and keep move on. And so we finish. After we finished, we need to use the result at I, and it will get the square, and we need to actually square it. We need to actually really square it, right? And then we can return the result. We are done. So finally, we can define the function sorted squares, and the element the parameter is self. Length is with what we input, and it is a list. Inside the list is an integer, and it will return a list with an integer element, and we done and give them an indentation to make sure it is inside the function and class solution, and make an indentation again. So we are done. We can print them out. Print solution dot sorted squares, and let me get input data to check whether it can. Yes, it works. Let me check another. So let me analyze the time complexity and space complexity. I will analyze the time complexity first. And we can see there's only one for loop here, and it starts from the n-1 and goes until 0. So n is the numbers of elements in my input array. So there's only one for loop going through once. So time complexity is just O of n. And as for the space, I just declare an output array of length n, so the space complexity should be O of n 2. And because I didn't extract any extract memory other than that, so we are done. Thank you for my solution video.